group project by Dalton Cole and Catherine Martin, and today we'll be talking about white dwarfs, neutron stars, and black holes. Our first topic, we'll be discussing white dwarfs. White dwarfs are remnants of stars that are also composed mostly of degenerate electron matter. They're hot and tiny compared to the sun and roughly the same size as the Earth, but it's hard to see with its low luminosity. That can also only be seen by telescopes as well. In front of you we have the HR diagram, which is the Hertzsprung-Russell diagram, where stars are represented as dots. And as you can see, we have our white dwarfs in the left bottom corner, where they are amongst the blue giants, the red giants, and the main sequence, which comprises all three. Out of all the stars in our neighborhood, only 8% of them are white dwarfs. White dwarfs are created after the hydrogen fusing period on a moderately sized star finishes and becomes a red giant. The carbon and oxygen in that red giant builds in the center of the red giants that aren't hot or big enough to fuse the carbon. Once it becomes a complete planetary nebula, a white dwarf is left, and that's how they are created. We will now move on to neutron stars. Neutron stars are formed when stars with masses between 8 and 25 explode into a supernova. The expanding cores are stopped by outer layers, and the cores remain intact as neutrons. Here's some basic info on neutrons. They are comprised of stellar remnants. Their mass is between 1.25 and 3. The cores of type 2 supernovas become stars, and there's a lot of pressure needed in order for the neutrons to remain stable. Next, we will be talking about pulsars. Pulsars. What are they? Pulsars are rotating magnetized neutron stars, and they emit radio waves in pulses. And now I will be talking about black holes. Now here is a black hole's nature. They contain matter in the center in a ring. Its boundary is shaped just like a spear. It either has a net electric charge or doesn't, but it's commonly believed that they don't. And they either rotate or they do not rotate. Now here are the boundaries of a black hole. Again, they're shaped like a sphere, known as the event horizon. They separate the entire universe. There's no radiation that escapes the black hole, and there is no mass. Now here's some more information on the boundaries of black holes. All information on black holes is based on relativity. The distance from the center of the black hole to the event horizon is called the Schwarzschild radius, and the diameter depends on the mass, and the more bigger the black hole, then the bigger the diameter. So what happens when you fall into a black hole? Well, your internal magnetic field is lost. The energy radiates to gravitational waves and other forms of radiation, and matter loses all trace of position and origin. Protons, neutrons, electrons, atom, and everything else that comprises the mass is lost. So what else happens when you fall into a black hole? Well, it's like spreading a piece of dough or Play-Doh. One side of it is put in your hand, which would be the event horizon, and the deeper part of the black hole which you had fell into is the stretchiness of the dough in the other hand. The matter depends on whether it'll be a more harmonious stretching into the black hole or will it be more vicious. Light becomes red, that is at the top of the event horizon, and time slows down a lot more as well. There are also black holes called Schwarzschild black holes. They are non-rotating, where basic physics apply. They're predicted that mass collapses into infinite density, and that volume in these black holes are empty, and that everything falls into the black hole. There are also black holes called Kerr black holes, which are rotating, and they're also formed with angular momentum. They're ring-shaped and also empty. Space spirals around it, and everything flows into these black holes. The ergo region is a region of space outside the horizon that is spiraling. It forces objects into the black hole. Objects can fly out of it because it is an area that is moving so fast sideways, and if the object stops, it falls into the black hole. Okay, so there's three types of black holes, and I will discuss what they are and how they are formed. There are the supermassive black holes, which are comprised of millions and billions of solar mass, could have formed very early from condensed gas and collision of stars. There are intermediate black holes, which are hundreds to thousands of solar masses, and they are formed from star collisions. And finally, there are primordial black holes, which are only a few grams, and they are comprised of tiny amounts of matter compressed in the beginning of the universe. The most important takeaway that everyone has to remember is that the universe, which is comprised of so many planets, stars, black holes, and other galaxies, are comprised of all masses in which we are all interconnected and together on. So the one source that we used was the textbook that we have in our class, which is Discovering the Essential Universe by Neil Cummins, and it's a great read, and it provides us with all the information. Here is the source in APA format.